1. You are multiplying and dividing rational expressions. Okay, we're just going to start right into examples. We have to remember our rules. Okay, when you multiply things with like bases, we add their exponents. When we divide things with like bases, we subtract their exponents. Okay, so first example, it says 5ab squared over 6b squared multiplied by 12a squared b squared over 3ab cubed. Okay. Now these seem somewhat difficult at first, but remember that when we had things before that were all thrown together, those were all multiplication too. The only difference is when we have a coefficient, we have to multiply them. So 12 and 5 will make 60. Okay, so 12 and 5 makes 60, and then we have a and a squared multiplying together, which make a to the third. Then we have b squared and b squared, which make b to the fourth. Any questions there? Okay. On the bottom, we don't have any other coefficient on the bottom. Wait, that's a 6. That's a horrible 6. I can't even read my own handwriting. Okay, so there we go. 6 and 3 make 18, right? And then there are no more a's, so I'm just carrying over this a. And then b squared and b to the third make b to the fifth. Okay, and then I'll simplify it. Now, of course, you could have simplified at the beginning. That would have been fine by me. I don't care. I'll show you both ways eventually, okay? So for right now, we're just going to start with multiplying straight across, then simplify. So I want to move the smallest one, or the one closest to 0, right? I want to move it first. So this a to the 1 will go to the top, so it becomes subtract 1. So I'm just leaving the regular numbers right now, 16 and 8. We got a squared, and I'm going to move b to the fourth to the bottom, so it becomes negative, and it becomes just b on bottom. So now my variables are good. I just need to simplify my 60 over 18. And if y'all guys ever get to the point where you're overwhelmed with fractions, remember that you can do this, 60 divided by 18, and you get 3 1/3. Now you can convert that to a fraction by pressing math and fraction, and it'll pop it out. It's 10 over 3. Okay, so if you ever feel like you're being overwhelmed, calculator to the rescue. 10 over 3. Yeah, so 10a squared over 3b. Any questions? Next example then. Now these start getting big rather quickly. Okay, we start seeing we have to factor stuff in order to do our canceling. So just like we had variables here that we can move and cancel out and all that jazz, we'll be able to do that same kind of concept, but with factoring included. Remember, you can't cancel anything unless it's being multiplied. And in the case of a binomial, you have to factor it first. So here we go. 15x minus 3x squared over x minus 9 multiplied by x squared minus 8x plus 15 over x squared minus 10x plus 25. I need your work, Jamie. Your work. Okay, so in order to simplify this down without doing some crazy business by multiplying x minus 9 and all this business on the bottom, I'm going to try to simplify it first. So what I'm going to do is I'm going to take this first little bit and deal with it like it's a separate term. I'm going to see if I can factor out anything out of this. So looking at the top of this first one, is there anything that I can factor out of there? Oh, I'm sorry, this is x squared on bottom, by the way. I can factor out a 3. That's true. So I can factor out a 3. What else can I factor out? X, right? So I can factor out a 3x. So if I factor out a 3x, I'm left with 5 up front, and I'm left with a minus x in the back, right? Okay, that's pretty much as far as I can factor this one, right? I'm going to move over to the bottom side. This x squared minus 9. I want you to remember that this is really x minus 0x's or plus 0x's minus 9, right? That's the same concept. So I need to factor this. It's called something special. It's called a difference of two squares, so I can factor it really quickly. How do I do that? It's x up front, right? It's two sets of principles, and then we minus 3 and plus 3. Difference of two squares. This is a perfect square, this is a perfect square, difference of two squares. Okay. Now I'm going to factor this one, the top side of this one. So first thing I need is two sets of parentheses, and I start by saying I know that my fronts have to be just x, right? And then I look at my back side. I see same sign sum. My same sign is going to be negative. And I'm looking at this going, what is factors of 15 that will give me 8?
5 and 3.
5 and 3. Okay, good deal. Now I'm going to factor the bottom, set up two sets of parentheses, look at my back sign. It tells me same sign sum. That same sign is going to be negative. I see this up here, so I'm going to go ahead and put my x's up front. Factors of 25 that will give me 10. 5 and 5. Simple enough, right? Now I can start to cancel a whole bunch of jazz. So, here we go. Gone, gone. I have a minus 3 and a minus 3. Is there anything else that you see that we can cancel? I see what you're trying to say. What if I had factored, instead of factoring out a 3, what if I had factored a negative 3 out? Then this would be negative and this would be positive, right? Or flip-flopped, if I use the commutative property, I can go x minus 5, right? So now it would cancel. So now I'm left with, the only thing that's left up top is negative 3x and x plus 3 on bottom. See it all? So there's a lot of factoring, and then you can cancel out. But you cannot cancel until you factor. Okay? Any questions there? Now, if I want to identify things that are excluded values, I have to look at what would make the bottoms of any of these equal to 0, right? So I'd set every one of these equal to 0 and say the excluded values are, and then I'd start looking at them. X minus 3 equal to 0 is x cannot equal 3. X plus 3 equal to 0 is x cannot equal negative 3. And then x minus 5 equal to 0 is x cannot equal 5. Okay, any questions on excluded values? Okay. So there's our two parts of our answer. Excluded values and the total there. Alright, let's do another example. Let's do C, I guess. We get 5x plus 10. And then on the bottom I have 3x squared plus 2x minus 1. Okay, I am going to stop there and start factoring immediately. Okay, so I have 5x plus 10. What can I factor out of that? I can factor out of 5, so I'm left with 5, open parentheses, x plus 2, right? On the bottom, I can factor that out. I need to set up two sets of parentheses. Because the back side is a negative, I know I'm going to have different signs. Because the front side is prime number, I know I'm going to have a 3 and a 1. And now I just have to decide what are factors of 3, right? Because we're using AC method. What are factors of 3 that when subtracted give us 2? It's fairly obvious. 1 and 3, right? So we need to create a 1x and a 3x when we multiply. So looking at the factors of the backside, it's just going to be 1 and 1, right? So I need to figure out where my negative is going to go. Is my negative going to go with the 3 or is it going to go with the 1? It's going to go with the 1 because I need a positive number, right? So now when I multiply my 3 by my 1, I need it to be positive. And when I multiply my 1 by my x, I need it to be negative. So there's my factors. I have 3x minus 1 and x plus 1 as my factors. Okay, now I'm going to go to the second piece. We have 9x squared minus 1 over x plus 2. That's nice. I don't have to do anything to that bottom piece yet. So this piece, I can't factor it anymore. I'm just going to rewrite it. And I can also notice that it cancels, so I'm going to go ahead and do that. The one up top, however, What is that? We just did it in the last problem.
Squared perfect square would be
3x minus 1 and 3x plus 1, right? So it's a perfect square up front and a perfect square in the back. So 3x minus 1 cancels. Bland. That one's gone. Next piece, we have x plus 1. Yay, I don't have to do anything with that. And 15x. So I'm just going to rewrite my x plus 1. And it cancels with this x plus 1. And then what can I factor out of my 15x plus 5? 5, and I get 3x plus 1, right? 3x plus 1 cancels, 3x plus 1 cancels, 5 cancels, 5 cancels. What's left? So what is the answer? Infinitely many solutions. We're getting a little too involved in math. If I cancel everything, for example, if I had down to 5 and 5, what is 5 over 5? So the answer is 1, right? The only way I can have infinitely many solutions is if I have multiple equations, right? So the answer is just 1. Just the answer is 1. If everything cancels in a fraction, then the answer is 1. Okay? Any questions before I move on? Speak now, forever hold your peace. Okay. On part D, the top is x plus 4, right? The bottom is x squared minus 4. So I need to factor that out. X squared minus 4. What does x squared minus 4 factor out to? 4x, sorry. What can I factor out of this? I can factor out an x. So x is on the outside. I'm left with x minus 4, right? So that part was easy. Next it asks us to factor out 2x squared minus 9x plus 4. So I can do that. That's fine. Remember, it's just over 1, so it's still kind of a fraction. I set up 2 sets of parentheses. And then I look at my back sign. It tells me same sign sum. This one tells me that it's going to be a negative sign, so they're both going to be minuses. 2 is prime, so I'm going to have a 2x and an x. And I say, what are the factors of 8, because we're using the AC method. Factors of 8 that when added together, because the back sign is a positive, will be 8 and 1, right? So 8x and x. Then I go, okay, so the back side is going to be either 4 and 1 or 2 and 2, right? It's got to be 4 because 2 and 8 divided will give us 4. So I need to multiply here to get my 8x. So there we go, there's my 4. And I need to multiply here to get my 1x, so that was easy. And I see another canceling. And I'm left with x plus 4 multiplied by 2x minus 1, right? I'm running out of room, so I'm going to try to write that really small. So that would be my final answer right there. So if it doesn't ask us to refoil that, then I'm going to leave it alone. Okay? Don't work any harder. Oh, I forgot about my x. I didn't cancel out that x right there. So it's still over x. Don't forget about that guy, I guess. Okay, now any questions? What would be my excluded values? X cannot equal 0, right? Because this is multiplied out. What else could x not equal? Notice the negative 4 here. Minus 4. So it cannot equal positive 4, because I got to let that equal 0. If I do my excluded values in the one above it, I have to set each of these equal to 0 and see which ones, or see what those are. So we get negative 1, we get negative 2, get negative 1/3, and positive 1/3. Alright. So, I wish that was all, but it's not. Okay, reminder, what is a reciprocal? It's a fraction what? Flipped, right? So a reciprocal is a fraction flipped. It doesn't change what a reciprocal is when we start dealing with a lot of variables. It's still the same thing. So we still can't divide fractions. We have to multiply by their reciprocal. So if I have numbers like 12x to the third over 5y divided by 4x to the fifth over 5x to the third y squared, I still have to multiply by its reciprocal. So the first part stays the same, and then I multiply by this fraction's reciprocal. So the 5x to the third y squared goes up top, and the 4x to the fifth goes on bottom. Okay. Now, when I told you earlier that we were going to start to see how we can cancel some stuff out without multiplying it first, this is where we're doing that. Okay. So I see a 5 and a 5. Those cancel. I see a y and a y. Which y should I move? The 1. 1 with a 1. So it moves up to the top, right? And here I have an x to the fifth, which needs to be combined with both of those, right? So I'm going to leave that one alone for the time being because there's two x's. I could move it. If I did move it, it wouldn't be wrong. It just wouldn't make another step. Okay, and then I have 12 and 4. My 4 will cancel to a 1, and my 12 will turn into a 3. Right? So now all I have up top is 3, and then I have an x and an x, which makes x to the 6th. And then my y, 2 minus 1, which is just y. Then on bottom, I have x to the 5th. Now I just need to finish simplifying that. Which one do I move, the 5 or the 6? Move the 5, right? So subtract 5. So I'm left with 3xy. Once I'm all said and done, it's just 3xy. Now, in your book, it shows it over 1. You don't have to write that step if you don't want to. It did not. 3xy.
Oh, you have 5y.
My 5 canceled with my 5. My y moved to right here. Because it only cancels at one of my y's, right? This same method could be applied if you expanded it all the way out and then combine it all again. Yeah, I think y'all did that in like Algebra 1. So if you still feel comfortable doing that, have at it. I don't care. Go ahead. Okay. Now, if it asks you to evaluate it at a certain number, which this one does, it says x equals -2 and y equals 3, it's easier to simplify it, then evaluate it, than to plug all these into these different spots and then evaluate it. Because if you mess up one number, your whole thing goes wrong. And you end up with really large numbers sometimes. Okay? So the easier way to do this would be x times y, which is -6, times 3, which is -18. See, I can do that in my head, but doing it from the original, I definitely can't. Okay, so you're just plugging them back in. It's not anything different necessarily. On B, they give us x plus 1 over x minus 2, and then they say divided, so you should automatically think I have to multiply by its reciprocal. I wouldn't even write down the original problem. I would already write down I'm multiplying by the reciprocal, so I'm flipping this fraction. So it's x, ooh, that's really small print, x squared minus 2x over x squared minus 3x. So I went ahead and flipped it as I wrote it. And then, of course, I need to factor out on each of those. The x plus 1 is done. X minus 2 is done. I can't do anything extra with those. But I can factor out what out of the top of this one? X, right? So I get an x minus 2. That's nice. And then on the bottom, I can do the same thing. Factor out an x, and I get an x minus 3. That's not... Oh, that one doesn't cancel. Sorry. So I'm done for the canceling part of things. But what about this x? Can I cancel it? Yeah, why not, right? So cancel out those x's. I'm left with a, as soon as I can get my pencil to start working again, I'm left with an x plus 1 over an x minus 3. Right here. Good? Questions, comments, concerns? Take a look at example 3. Tell me what you think. If we need to do it, we will. Okay, example 3. And again, I'm going to write down my reciprocal as I get to it. Okay, so I have 45 over, and they give us x squared plus 2x minus 15. I know I'm going to have to factor that, so I'm going to go ahead and factor it now, so I don't have to rewrite it twice. So I set up 2 sets of parentheses, right? I look at my back term. It's a negative, so I'm going to have a different sign difference, a minus and a plus. I look at my front term. It's definitely going to be an x, since my back sign is my back sign is negative, and my number is 15. I'm looking for factors of 15 that, when subtracted, will give me 2, 5, and 3. So since my middle term is positive, I'm going to put my larger number with the positive, and there we go. So that one's factored. Multiplied by. Up top, I have 2x squared plus 10x. What can I factor out of that? I can factor out a 2x. So 2x gets factored out. I'm left with an x plus 5. Nice, because that cancels. On bottom, I'm left with 5x squared y, which doesn't do me any good right now. Okay, and instead of writing divided by, I'm going to write multiplied by, and I'm going to go ahead and write the reciprocal, x minus 3 over 1. X minus 3 cancels. My 5 and my 45 go into each other, so that one's left with 9 up top. This x can go down here, and then I just need to rewrite what I have left. So I have 9, that's it, I guess. 9 up top. On bottom, all I have is x to the 2 minus 1, which is just x, and I have y. Oh, I just canceled my x. I didn't cancel my 2. Thank you for catching that. So those two are multiplied by each other still, right? Okay, any more questions? I have faith that y'all guys can multiply.